So welcome back, guys. So today we're going to look at two things. We're going to look at adding terms in a radical form, and we're going to look at adding and subtracting them, and then we're going to look at manipulating expressions inside of radicals. So the thing that you need to do in order to add or subtract radicals, this is what needs to happen. Okay, inside of the radical, this number needs to be the same. The radicands need to be the same. All right. Also, the power of the radical. The power of the radical. We don't call it a power. We call that an index. The index of the radical needs to be the same. So the index needs to be the same. Okay? So this is your homework for tonight. This is part of your homework. This is homework number 3. And then you also have another page of homework. Okay? But I just wanted to start there first. But we're going to scroll back a little bit and go to some previous pages here. So here we go. So we're at the bottom here. So when we're adding and subtracting radicals, radicals are similar to like terms and must have the same root and the same radicand, or the number inside the radical. So what do not like radicals look like? Not like radicals will be square root of 5 and the square root of 15. They have the same root, but different radicands. The square root of 2 and root 7 and 7, well, the index is 7 of 2. They have different roots, but the same radicands. Now, like radicals, these are like radicals. I have the square root of 5 and 2 square root of 5. They have the same roots and the same radicands. For 3, root of 7, 2, and 5, actually you say 7 root of 2. That sounds weird. Have the same roots and the same radicands. So first, combine. Sorry, not first. The first thing we're going to do today is we're going to simplify all radical terms. Then we add or subtract like radicals. And like radical terms have the same roots and the same radicand. And the last thing we do is add or subtract all other like terms. So the thing we're going to have to recall is how to use our graphing calculators to simplify the radicals. So we have to simplify, add or subtract the like terms, and then add or subtract all other terms, right? So remember, simplifying, we go to y equals, we look at the index here. I always put a 2 there. And we go to y equals, we go put in 44 divided by x squared, right? And then we go to the table, and we're looking for, what we're looking for is, to put it in the simplest terms, the x value paired with the smallest whole number y. Whole number y1. Okay? So for 44, I'm going to put it in my calculator. I'm going to go to my calculator, go to Y1, and type in alpha y equals, I want to clear it out, alpha y equals, right? Oh, I got to change that. So 44 divided by x squared, close parentheses, and press second table, looking for my smallest y, and remember we never have negative values of x, so we always start at 0. Smallest y is 11, so it's 2 root 11. Simplifying, I get 2 root 11 plus, for 99, I'm going to put in y equals 99 over x squared. I'm looking for the smallest y. So to y equals, type in 99, second table, smallest value will be 3 root 11 plus 3 root 11 here. And the last one, negative 3 times root 11. There is no smallest value there. So the next step, we simplified. So these were my steps. I simplify. Number 2, combine like terms. Right? So 2 plus 3 is 5 root 11 minus 3 root 11, and I get 2 root 11. Right? Now I'm going to simplify 72, 98. And I don't have to worry about the last one. So 72, so I go to y equals, type in 72, second table, and I get smallest y value 6 root 2, or 6 square root of 2. Right? Plus, you do 98. Second table, and I have 1 and 98. I'm going to keep going. That doesn't look right. 7 root 2 plus 7 root 2. Okay, combining like terms, I have 13. 6 plus 7 is 13. Root 2 minus 4 root 2 equals 9 root 2, right? Now the next one, look for the like terms. My like terms here, these are my like terms. That means I combine those. Oh, nope, nope, nope. Be careful. Don't make the same mistake I made. I'm going to highlight my like terms here. My pen's not working. So here's a like term, and here's a like term. Here's a like term, and here's a like term. So combining my root 5s, I have 8 plus 5, or 13 root 5. Negative 3 plus 7 is positive 4. Right? Moving on, below are a few more challenging examples. Now, so it looks like I don't have to simplify here. The numbers inside are primes that can't break down any further. But I need to take care of this 32. So I'm going to go to my calculator, type in 32 over x squared, right? Second table, and I have 4 root 2 plus 4 root 2. So I need to be careful here. I need to be careful. Plus 4 times 4 root 2. All right? And over here, everything else, it just comes down. Okay? So combining my like terms, if you don't see them, I'm highlighting them for you. 3 square root of 5, 10 square root of 5, and I get 13 square root of 5. My other like terms, well, I'll have to simplify here. So I'm just going to write them out and scratch out the ones I already took care of. Minus 5 square root of 2 plus 16 square root of 2. 4 times 4 is 16. Okay? Simplifying, I get 13 square root of 5 plus 11 square root of 2. Next problem, I'm just simplifying. So losing the parentheses, there's nothing I can do to the first part. 12 plus 3 square root of 7. Now I do have to distribute that negative to the 4. So negative 4 and to 5 square root of 7. So negative 5 square root of 7. Combining the like terms, I have 12 and negative 4. That's going to give me 8 equals 8. And then I have 3 minus 5, or negative 2 square root of 7. All right, and that's my final answer. Now for number 3, we have to be cautious and careful here. You have to be cautious and careful. So this is what we're going to do. We're going to say 1 times that quantity. So 1 times the first. So first, I like to write it out outer, inner, and last. So 1 times the other first term. So 1 times 5 plus we know this is 6 square root of 2. But actually, you know what? I don't want you to be confused. So the square root of 72 plus the square root of 72, that's my inner, times 5. That's okay. We're not going to use this method. Okay? And then 1 times square root of 2 plus square root of 72 times 5. I kind of want to rewrite that so it's a little bit farther this way. So I'm just going to go through and simplify here a little bit, but let me get that last part in there. Square root of 72 times the square root of 2. Now I have 5 plus 5 square root of 72 plus the square root of 2, or 1 square root of 2, plus the square root of 72 times 2. Remember, we can just multiply those things inside of the radical. That's going to give me 5 plus 5. If I simplify this part, I get 6 square root of 2, 6 root 2, plus 1 root 2, plus the square root of 144. That gives me 5 plus 30 root 2 plus 1 root 2 plus 12. Simplifying, I get 5 plus 31 root 2 plus 12. Or 17 plus 31 root 2. Final answer, right? Next, the cube root of 16 and the cube root of 128. So what we're going to do is we're going to say 16 over x cubed in our graphing calculators, right? So y equals 16 over x cubed, so up arrow cube, second table, and I get 2 cube root of 2. 2 cube root of 2 plus 5. Okay, now I'm going to simplify this number. Remember, we're multiplying that 5 by whatever we get in that root. So 128 over x cubed. 128 over x sparrow 3. Second table, and I get 4 root 2. 4 cube root 2. Okay, simplifying, I get 2 cube root of 2 plus 20. 5 times 4 is 20. Cube root of 2, I get 22 cube root of 2. That's my final answer. Okay, now yeah, that's it. For the next one, we have 4x plus 2 times 2 plus 8x. You can just pull it out of the parentheses. Minus 6 times something. 6 times 4. The cube root of 64 is 4. Combining like terms, I have 4x's plus 4 plus 8x minus 24. Here's my like terms. That's 12x's minus 20. And here's my final answer, guys. Okay? Number 6, I have 7 minus 6 root 2. Plus, if I go back up, I did the square root of 98 up here. That simplifies as 7 root 2. 7 root 2 minus 4 root 2 plus 4. Simplifying, here's my like term. 7 plus 4 is 11. Negative 6 plus 7 is positive 1 root 2. So these all go away. And I'm left with minus 4 root 2. I get 11 minus 3 root 2 equals 11 minus 3 root 2. Okay? Now here, we're dealing with negatives, square root of negatives. So we have to simplify these answers. I get I square root of 5 plus, okay, the square root of 125. I don't know, so I'm going to go to my calculator. But one of the things I do know is that, that's the wrong thing, guys. I apologize. Is that there's going to be an I out here, but I'm going to have a square root. Okay? So let's go to the graphing calculator here, put it in. We have 125 divided by x squared, and just get those roots fairly easily, right? And it looks like the smallest one is 5, square root of 5. So I'm going to write my 5 on the outside and then my 5 on the inside. Minus, square root of 4 is easy, but you need to put your I out here. Square root of 4 is 2, so it's just 2i. Now combining like terms, these are my like terms. I have 1i square root of 5 plus 5i square root of 5. That's 6i's square root of 5 minus 2i. And it's okay to refer to it as an I. You know, you can get more savvy about your imaginary numbers when you get 100% on this next test. How about that? For the next part, I'm going to go a little bit quicker maybe. So first we need the square root of negative 75. This is a negative. It produces a I on the outside. On the inside, I'm going to get something else. Over here, for the next one, I'm going to produce an I on the outside. On the inside, I'm going to have something else. And for the last one, the negative, so it says minus, I'm going to have an I on the outside, and that 3 is prime, and it just stays inside. Okay? So let's go ahead and take care of 75. find that root for 75. 75 over x squared, and my smallest number is 5. 5 root 3. 5, so I put a 5 out here, 3 inside. And I can tell you for 48, well, I'm going to table that and just make sure we do it in a calculator. So 48 over x squared, second table, looks like 4 root 3. 4 root 3. Now we can combine like terms. These are all root 3's, and all I have to do is combine the like terms. So 5 plus 4 minus 1 is 8i root 3. Final answer. Number 9, you can do on your own. You just distribute. You can redistribute. So 3 to all of this. 3 times 5 minus 6 root 2 minus 4 square root of 2 times 5 minus 6 root 2. Right? Simplifying, I get 15 minus 18 root 2 minus 20 root 2 plus 24 times 2. All right, simplifying, I get 15 minus, let's see, that's 38 root 2 plus 48. Simplifying, 48 plus 15, I get 63 minus 38 square root of 2. What about the next two? Next 2 or 3. You can do 10, 11, 12 on your own. But for number 10 and 11 are very similar. You're just squaring both of these. This equals the square root of 3 plus the square root of 5 times the square root of 3 plus the square root of 5. So what I do, like I just did, so all of this times all of that quantity, and this times all of that quantity. So square root of 3 times the second quantity, okay, and then the square root of 5 times square root of 3 plus 5. Okay, simplify, I get 3 plus square root of 15 plus the square root of 15 plus 5. Simplifying, I get 2 square root of 15 plus 8. So you should be able to do 11 and 12 on your own. All right? And so make sure you've already done this homework because I'm checking for it. But tonight's homework is going to be this one. You do have an additional part to this video today. So make sure you check it out. Have a good day. This is adding and subtracting radicals.